Hi, students. This is Miss Peterson, and I am going to go through with you today about um, the Gizmos Faces of Matter in case you missed sessions last week. Um, and you're going to go ahead and go into this Gizmos Faces of Matter, and you're going to go ahead and open that up, and it should make a copy inside your own drive. So be sure that you're logged into your at stpaul.k12.mn.us address and your SPPS apps. And then this should make a copy inside that drive for you, your own drive. All right, so where do I get this information? Where do I get this gizmo? So I'm going to go here to the Schoology, sorry, back to Schoology. And I'm back in that folder, that week 2, because that's where my gizmo is. The Gizmo Faces of Matter. And I see that Miss Peterson's Clever homepage is here, and it says access the apps here. So I'm going to go in that link, and that will bring me, and I'll have to click that little right arrow, that little right arrow to bring me out. And that would bring me to this page, the Teacher Clever page. Here's Miss Peterson's page, and I actually sent out a notice you'll need to access my teacher page to use the Gizmos app. And here's the link to the teacher page. So hopefully there's more of you that are checking it out. And see, I can see who's on the left-hand side checking it out already. And then I'm going to go down to that Earth Science, and there's Gizmos. All right, click the Gizmos. And we're going to do the phases of water. And here we go. We'll launch this gizmo here. And let's take a look at the questions. So basically, the questions ask me, oops, that's the wrong gizmo. There we are. It asks me a pot filled with water or with snow is left on a hot stove for a while. What will happen? Well, snow is water. So go ahead and make a hypothesis. What would happen? And then number 2, a phase is a state of matter, such as a solid, a liquid, or a gas. What phases would you see? Explain. Likely, if it's in a hot pot, it's going to go from a solid to a liquid to a gas, and you'll see all 3 phases. Number 3, a phase change is a change from one phase to another. What phase changes would you see in this example? So if it goes from a solid to liquid, what is that called? And then if it goes from a liquid to a gas, what is that called? And write down what those phase changes are called. Okay, well, we're going to learn more about those 2 phase changes quite a bit in this gizmo. So in the phases of water gizmo, you can heat up or cool down a beaker of water. So we're going to heat it up, the water, wait until the temperature stops rising, and we will observe. We're also going to see you'll figure out why do you think the lid lifts up. And number 3, then we'll also chill to remove the thermal energy from the water, and what happens. So I'm going to go ahead and do that now. First we'll heat it up. And you can drag this magnifying lens, and you can access this through the Clever, my teacher Clever page if you want to do this on your own and play around with it, which I encourage you to do. So here it's reached boiling point, and notice that at boiling, the temperature does not change because all the energy is going into making this liquid turn into a gas. All of the energy is being used by the substance to change phases. So you'll see that the temperature stays the same. And you also notice the gases are quite spaced out and they fill the entire container. And there, the last bit of the water is boiling, and now you'll see that the temperature starts to go up again. Gases are spreading out and filling the entire container, and you can see that The gas phase is the one that's pushing the lid up and expanding the most. Take up the most space. Now we're going to chill it down. And you'll notice that that pot lid's coming down because these gases are starting to slow down because they're taking thermal energy away from the system. And then you will see that at 100 degrees, not only is this boiling point if we're adding energy, but when we're taking away energy, it is condensation point. So the gas is condensing back into a liquid. All right, and again, it stays at 100 because at this point, all the energy is going into changing the gas to a liquid. So the temperature remains the same until that happens. No more gas, it's all liquid until we reach 0, and you see that at 0 is freezing. It's freezing point. So not only is it melting point, but it's freezing point. And you'll see that the molecules of the solid are in this fixed state vibrating. Okay, so let's go back to our task. And you will answer those questions. And then number 1, we'll observe the gizmo. Solid ice is gray, liquid water is blue, water vapor gas is light blue, heat or chill. And I want you to highlight one of these, either solid, liquid, or gas at -20, at 30, and at 105. All right, we're going to do that along with this part 2. So I want you to go ahead and make a hypothesis. How does the temperature affect the phases of water? So if we increase the temperature, what's going to happen to the energy of the molecules? Is the energy of the molecules going to increase, or will they decrease? And if we decrease the temperature, what's going to happen to the energy of the molecules? Is it going to increase, or is it going to decrease? So if we increase the temperature, what happens to the molecules? What kind of phases are they going to go through? And then if we decrease the temperature, what's going to happen to the molecules? What kind of phase changes are they going to go through? And then I would like you to go ahead and make predictions. What do you think it's going to be? Solid, liquid, or gas at -10? Solid, liquid, or gas at 10, at 50, at 90, at 110 degrees, and 120 degrees Celsius. So what kind of state of matter do you think it's going to be at all of those? And then we'll do the simulation. So pause and write your thoughts. Pause this video and write your thoughts. Okay, I'm going to go ahead. I'll go through. You're rejoining me here in the video. Go through the phases of water and what happens here. So first, looking at that -20, we're already there, right? So what is it? Looks like we are freezing, right? Let's go ahead and heat it. I have a cat frozen on my lap here joining us. And you'll see that the solids are fixed molecules and they make a crystal structure, crystal lattice, don't they? But now it's melting at 0, and then it's turned to water, which is more of a fluid, free-flowing phase, and they move around each other. They have some attraction to each other, but not as much as when they're in solid, because each of the molecules has a little bit more energy, so they're moving around each other, and they don't have a particular shape. Right, and then at 100, it's boiling, as you can see, and the molecules are turning to gas, which, wow, they take up as much space as possible, And if they bump into each other, they bump into each other. It's rather random because each molecule has so much energy, an enormous amount of energy, that they are moving as fast as possible and filling up this entire container. Okay, filling up the entire container. All right, notice the temperature. Okay, so I'm gonna do this one more time. I'll chill it down. And I'm gonna use some tools to kind of make some. So right here, the gas fills up the entire container. So the red is the gas. And then this one, we're going to mark the top of the liquid when it turns to a liquid. So everything above 100 is gas. Then when we get to 100, it condenses. This is condensation point. And we'll mark the top of that liquid. Once the gas is all turned to liquid, then you can see the volume that the liquid takes up. Okay. And then as soon as that happens, as freezing happens, we're going to also make a note as to the top of the ice. I see that the top of the ice is there. So which one takes up more volume? Liquid or solid ice? Now we have to think. Water is a little bit different than some of the other kinds of substances. So the water molecules, they actually expand. So they do this when they freeze. So if the hydrogens are here, then they actually get wider like this, and we become it has a very fixed state. So we'll get to this state right here, and if there's more room between each of the individual water molecules and they spread out, then each one of them, when they get together in that crystal lattice, is going to take up more space. That's unlike any other thing. Like if I had a bar of gold that was solid, it would be much more packed and dense than if we melted it and it became a liquid, because then it would expand. But water is different this way. When it is a solid, it takes up more space than when it's a liquid or when it's a gas. Or sorry, when it's a liquid. Gas is the least dense. So let's go back to this, because remember, gas took up the whole space. Takes up the most volume. It is also the least dense because all these molecules are spread out so much. And we'll talk about what that means. So let's go back to here. So what phase is it? It is -20. It is a gas. So we would highlight gas. Sorry, solid. What phase is the water at 30? 30 degrees Celsius is 30 degrees above zero. It is now turned into a liquid. So we'll highlight this one. I'm just going to turn it green. And then here we go. Turn that liquid there. And then into a different color here. I'm just going to use green. That's good color here. And then gas is at 105. Then here, if we were to talk about it, at -10, it is a solid. At 10 degrees, it is a gas. What did I say, gas? Sorry, liquid. At 50, it's still a liquid. And at 90, it's a liquid. Okay? At 110, it is above 100. It has turned into a gas, and same with 120 degrees there. So these are the answers, the actual answers for those. Okay? All right, questions at all? There we go, green. All right, and then we said at what temperature does water melt? I gave you that at 0, and it's the same as when it freezes at 0. Boiling is 100, condensing is at 100. Extend your thinking. I want you to go ahead and describe an example of a phase change you've seen in your real life. I always hate this part. Your ice cream melts before you get to eat it. Okay, so there's one example phase change. All right, the next one says, how are the phases of water different from one another? We're going to click chill until the water is completely frozen. What I want you to do is really look at the space that each phase takes up. So one of the 3 phases holds its shape. The other 2 do not. But based on your experience, which phase has a fixed shape, and which phases have a shape that can change? So stop right now and make your hypothesis. Okay, welcome back. We're going to go ahead, go through the phase changes, phases of water changes here. And I want you to notice, based on your sketches, why do solids have a fixed shape while liquids and gases do not? And I just provided those sketches here. Observe another way that phases are different is how they fill a container. Press chill until the water is completely frozen. Observe the ice without the magnifying glass. Does the ice reach the top of the container where the lid is? So if I look at that, whoops, we've already really done it, right? So here it is, the phases, phase changes, get phases of water Gizmo. And liquid only comes up to here, right? It does not fill up the container. Gas fills up the container. The gas is here. The liquid be, I'm going to actually redo this so we can see it, but so here we go. This would be the top of the ice, and the top of the liquid be here. So the ice takes up more space than the liquid. All right, here we go. I'm going to go ahead and heat it up. You will see that the ice is going to turn right back into the liquid, and it will actually take up less space as a liquid than it did ice. There it is, melting. And now you'll see this phase change from liquid into gas. And you're going to see that whole container fill up with the gas molecules. Right? So no longer are we liquid or solid, and solid was much more, took up more space than the liquid did. So I'm going to go ahead, and we would project that this whole container would go all the way up to the top if it's a gas. So I'm going to chill it down. And let's see where the liquid goes. There's your liquid. And now it's changing from that liquid form into the solid form. And you'll see that the solid fills up to the green arrow, and that's more volume than what the liquid took up. Okay, so let's go back to our Gizmo's phases of water. And it says, does the ice reach the top container where the lid is? That would be no. Does the liquid reach the top? No. Does the water vapor reach the top? Yes. What phase always fills its container? It is the gas. What phases do not always fill their containers? It is the solid and the liquid. the solid and the liquid. Okay, so now I want you to think about fishing. All right, Ms. Peterson, I fish occasionally, and I'll bring my fishing stuff. And let's say I forgot my tackle box, and I'm went up camping, and I don't want to go into town to buy tackles, so I find a little rock alongside the road, and I had some marshmallows packed for hot chocolate, and I said, okay, how can we use these, right? And so, what do we know about the marshmallow? Well, it has some sugar, and it's really squishy because it's got a lot of air molecules and space between the sugar, right? And the rock I found on the side of the road is about the same size, but it is more dense, and it's got tightly packed metal and other things that go into rocks that are a lot more dense. So if we look here, the density, into the introduction, the density of the substance refers to how much matter is packed into a particular space or volume. The denser the object, the more tightly packed it is. Objects that are less dense tend to float in denser materials. So if I'm thinking about using something to make my line float, I might tie on the marshmallow onto the end of my fishing line to make it float on the water. But if I want to go typically late and not pick the things up at the top like trout, I'm not fly fishing, but I want to go get the big one at the bottom of the lake, then I'm going to go ahead and tie that rock on because it is more dense than the marshmallow, and then I'm going to throw that line in, and then the line will sink down. So, question is, how do phases of water compare in volume and density? Here it is. Form your hypothesis. Answer these based on your experience. You've all had a glass of ice water, right? So think about it. Does an ice cube in water float or sink? Okay, what I would find out is that it sinks, right? B, when water boils, bubbles of water vapor form in the water. Do these bubbles tend to rise or sink? Those tend to rise. So which phase of water is the densest? The densest is liquid because it's found at the bottom of the water glass in your ice water. The least dense is the water vapor or gas because it escapes out of the boiling pot of water. Well, it leaves the liquid behind. All right, so in the medium density would be the ice. Observe. Be sure all the water is frozen. Open the tools trays at the right and drag an arrow to mark the top of the ice, then press heat. We just did that and watch until the ice was melted. Does liquid water take up as much space? So if we go back there to that phase of the water demo, nope, liquid water only goes up to here. This purple arrow, right, is the liquid water, but the ice, this green arrow that I'm moving around, is the ice, and that's the volume of it. Marking the volume of it is the green arrow, marking the volume of the liquid water. Here at this level is the liquid water. So ice takes up more space than liquid water. That's unusual, but here's my note. In most substances, the solid phase is densest. Water is highly unusual. Okay? So water is special. Those water molecules expand, and that's what makes the ice less dense than liquid water and has us have floating ice, floating icebergs, all of that. So does the liquid water take up as much space as ice? No. Then we wait until all the water vapor is boiled away, which takes up more space, liquid water or the water vapor. You would have the water vapor because it fills the entire container. Which phase of water is the densest? It is the liquid. And the least dense is the gas. Extending your thinking, looking at all three phases of water through the magnifying glass. How does the spacing of the molecules fit with what you found about densities of ice, liquid water, and water vapor? Well, if we look back up there, because I just went ahead and put them in here, liquid water, they're close, they're moving around each other, and they have no specific form, and they are the closest of the water molecules. Then ice molecules expand and they take up more space, right? And if we look here, the liquid that would have more water molecules there. The solid has less water molecules in the same space as the liquid. And the least dense is the gas, which has the least amount of water molecules in the same volume. Okay, thank you very much, and I hope this helped out. Try to keep it as short as possible. This is for people who miss the phases of water. Thank you.